Pi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
Okay, we're going to be talking about functions. Here's an example. This is an equation of a line, y equals 2x plus 3. This actually is a function. How do you know when an equation is a function or not? Those are something that we're going to talk about. First, I want to explain that why this is called a function. Y is a function of x, meaning we can pick values for x, and depending on what values we pick for x, that will determine y. So y is determined by what values we pick for x. So we call that y is a function of x. So, and then another way to write that is that you can say f of x equals 2x plus 3. When you see this notation, all that is saying is it's a function, that y is a function of x. And the way that that is read is, this does not mean f times x. That is read f of x. So that this implies function. This is a function notation. This is a function. All it does, it basically replaces y. So every time you see this notation of f of x in your brain, just say y. So here I'm going to see it, but in my brain I'm going to say y equals 2x plus 3. Because this basically just replaces y. Because y is a function of x. Just to show you how that is so, y is dependent upon what x is. So like, let's say we choose x to be 0. If we put 0 in here, that means 2 times 0 is 0, and 0 plus 3 is 3. We picked a value for x, and y was dependent upon that value. So y is a function of x. And this is why we use the notation f of x, meaning y is a function of x. Let's say I pick 1 for x. 2 times 1 is 2, plus 3 is 5. So if I pick 1 for x, y will be 5. Let's say I pick 2, putting in 2 for x. 2 times 2 is 4, and 4 plus 3 is 7. Okay, you have seen this XY chart doing that before. Okay, using function notation, what if I said, same here, what if I said I'm going to make x be 0? So we can write it as this, f of 0, meaning I'm putting in 0 for x, which means I put in 0 for x everywhere on the right hand side as well. And so f of 0, here's how we say it, f of 0 equals 3. Which is same here. It just basically made it into a coordinate. Same for here. If I want to say 1, I'm putting in 1 for x. Then I can call this f of 1. This is how this is read. And this means I am putting in 1 for x. 2 times 1 plus 3. So f of 1, meaning when x is 1, y is going to equal 5. Because remember, this whole notation can just be replaced for y. It's the same thing as saying y equals 5. F of 1 equals 5. Same with f of 2 equals 2 times 2 plus 3. F of 2, or if I want to say it y, equals 7. It's just a different way. Doing this is the same thing as what we're doing up here. Okay? On a graph, how do you know? Oh, the one thing I want to say about also a function, when your equation is a function, because you can have equations that are not functions, when you have an equation that's a function, each value of x has one and only one value for y. Okay, in other words, I can't put in 0 and get some other value for y. When I put in 0, I will only get one value for y. Okay, so each value of x has one and only one value of a corresponding y. Okay, so how do you know when this is an equation? A function. A lot of times you can graph it, and look, most of the times you do look at the graph and you can tell it's a function. Same if you have a set of coordinates, then what I just said, for every x value there can only be one corresponding y value. So if you have a set of coordinates, you can look at that. But when you have a graph, let's say we're going to graph this. This is a line. across the y-axis at 3, and then if I want to graph my slope, my line would look like this. This is the line of y equals 2x plus 3. Okay, not a very straight line, but that's the line of y equals 2x plus 3. Okay? You can say this is a function if it passes the vertical line test. In other words, if I take a vertical line, like this dry erase marker, it's a vertical line. If I can go across this line and only this marker touches only one point along this, then it is a function. Okay? So as I go across this line, my marker will only be crossing one point along the way as I go across. Let me give you an example so you know what's not a function. A circle, if I was graphing a circle, which that's like an equation, x squared plus y squared equals 9. That is not a function, because if I took this vertical line, I am crossing my graph up here and I'm crossing it down here, at a point up here and a point down here. I'm crossing 2 points. You can't do that for a function. Okay, so this is one way to know if something is a function, by doing the vertical line test. If it doesn't pass the vertical line test, it's not a function. Again, this vertical line is touching 2 points on the graph, so it's not a function. It can only be touching 1 point all along as you're going across that. So a line is a function. Circle is an example of something that's not a function. Once you determine if a graph is a function, then what you do is you state the domain and the range. Okay? Domain are all possible x values. All possible x values that you can have. The range is all possible y values that you can have. Okay? One way to remember this, d, x, r, y. Domain x, range y, dx, ry. If you say this fast enough, dx, ry. I had a student who liked to say, the eggs are white. Eggs are white. The eggs are white. dx, ry. dx, ry. The eggs are white. So dx, ry, the eggs are white, is one way to help you remember. Domain for x values, range for y values. Okay, so we set up above that the equation y equals 2x plus 3, or if you want to see it as f of x equals 2x plus 3, all I did was replace my y with f of x. Same thing. Okay, it is a line on a graph. It is a function because it passed the vertical line test. So once we say yes, it's a function, then we need to state the domain and the range for that equation or for that graph. Okay? Domain is all the possible x values. This line goes forever and ever in that direction, and it goes forever and ever in this direction. Are any of my x values limited? No. In other words, if I go this direction in my x, then I still will have x values in my line. If I keep going on my x-axis, I will have x values that are just keep increasing. Okay? Same if I go in the negative x direction. If I just keep going this way in my x direction, then I will have points down here. If my line just keeps going on forever like that, and I keep going way out here, then I will have a point down here. So the x values are not limited, meaning any line will fall into this well, I should say any line. Any line that's not vertical or horizontal, any line that has a slope will fall under this category. My x values are not limited, so my domain can be any real number. So either you can write all real numbers. This is one way you will see the answers written. All real numbers. You might see it in some sort of set notation saying that x such that, you might see a line that means such that x equals all real numbers, and you might see that symbol, and that just means x equals all real numbers. You can also see it written like this. with a parentheses from negative infinity to a positive infinity, meaning x can be any infinite numbers in the negative direction and any infinite numbers in the positive direction. So these are three different ways you could see the domain listed. Okay, now let's look at range. What is range? Range is all possible y values. So in looking at our graph, can I still see the graph? And looking at the graph, okay, if I go up in the y direction, okay, going up in the y direction, I still have a point over here. I still have y values. If I keep going up, that line will keep going, meaning there are still points over here in the y. If I go in the negative y direction, go down, and I go over, there is still a point. This point down here has some sort of y coordinate. If I keep going down, 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 that line will still continue to go on, which means that there are points on that line and they have some sort of y coordinate. So on a line that's not a vertical or horizontal, your range will be all real numbers, meaning my y values are not limited. They can be any number. So my range here would be all real numbers, meaning any y value can hold true for these lines. Again, you might see it as in a set notation form, y, such that y equals all real numbers, or you might see the word all real numbers here, or you might see it as, again, negative infinity to a positive infinity, meaning you can have negative y values going down the y-axis and any positive y value or y coordinate going up the y-axis. Okay, let's apply that concept to a couple of these problems to where they've given you the graph. So if you have the graph, it's easier to see if it's a function. If you don't have the graph, then I would recommend making a graph. Usually having a graph is the easiest way to determine if it's a function. Okay, 19C7. So you have this, it's basically hyperbolas. So if you did the vertical line test, you took a vertical line and you went across here, you can see that my graph is touching 2 points at the same place on my vertical line. These 2 points right here. When your graph touches 2 points on the vertical line, it does not pass the vertical line test and it is not a function. Here if I keep going, see I have 2 points. I'm always going to have 2 points. So the first question to answer, is it a function? No. When it's not a function, you don't even state the domain and the range. No need to, because it's not a function. We only state the domain and the range on ones that are functions. Okay, so now looking at 19D7, you have this graph right here. So the first question we have to ask ourselves is this a function? Does it pass the vertical line test? If you took this line and your dry erase marker, my vertical line, and went across this graph, will it only touch 1 point at every place on that graph? The answer is yes. Here it touches here, and as I keep going, it's going out 1 point, 1 point, 1 point. All along here, it's only touching 1 point on this vertical line. So it passes the vertical line test, so yes, it is a function. So when it is a function, then we have to state the domain and the range. Domain are all possible x values, okay? In other words, any possible x-coordinate that can be on this graph is what we're looking at. Any x-coordinate, okay? So this graph starts here and it goes this way, and it's going to just keep widening out, widening out, widening out as you go, both ways. It's widening out in both x directions. So here we're starting at 0. We can have 0 as an x-coordinate. We keep on going, and we've got points up here, so we have these x-coordinates, so you keep going the positive x direction, and will I still have x-coordinates along here? Yes, because it's going to keep widening out, meaning I can have all values of x as it widens out both in the positive and the negative direction. So there is no limit to what my x value can be because this keeps widening out in both directions. So, and it will go on forever. So since there is no limit, that means that my x values can be all real numbers. And we only deal with real numbers on a graph, not imaginary. So you can either write all real numbers as your answer, or you can also see it, you go from negative infinity to positive infinity. You always do your negative values first, your lower values, So in other words, on a graph, your x values can be all the way from negative, really, small negative numbers or large negative numbers, however you want to see it, negative numbers all the way to really high positive numbers. Okay, so these are two different ways that you can write your answer for your domain. Range. The range are all possible y values. There is a limit to our y values. If you look here, the graph stops right there. We don't have any y values up above that. Because if we go up any higher, if we go over here, this is where our y values stop. Y values are looking at the x-axis. We don't have any y coordinates, any points up here above 1, 2, 3, 4. Okay, this is 4 right there. We don't have any y values there. We have points all along this line, and that will be our highest y value. Other than that, our y values, we have a point down here, and it's going to be some negative y value. We keep on going, and it's some larger negative y value. Same in both directions. So this is my limit to my y values. My y coordinates will not ever be higher than 4 because I don't have any points up above here. Okay, so there are several different ways you can write this. You can write it as y. You can either write all real numbers less than or equal to 4 because we are less than 4, but since there is a point, since it's at 4, that's like having a closed circle right there, meaning we will include 4. So we can have the y coordinate of 4. So you can say all real numbers less than or equal to 4, so because we want any number but below 4. Or you can write it as y is less than or equal to 4. This means all y values that are less than or equal to 4. Another way to write it is we can go to negative infinity, meaning really large negative numbers. We can continue down. There's no limit to our negative y values. As you go down, the line will also go down as well. But there is a limit up in our positive values, so it will be 4. Our y values will not be higher than 4, but this side has a bracket. This bracket means that that value is included. You include that value. It's like having an equal sign, less than or equal to. That's what that bracket means, or equal to. When you have a parentheses, that means that value is not included. Having a parentheses is like having an open circle, meaning you don't include the number. We always use parentheses with infinity symbols because infinity is not a definite number, but you also use a parentheses if you're not including a number. This is just like having a less than or greater than with no equal sign on it. Okay? So this is 3 different ways that you might see your range values for your y values.